channel scanner option transforms the Agilent HSA into a complete multi-channel site survey and drive test system that logs received signal strength, time and date, and GPS position directly into the internal memory or to a USB memory stick. No external PC is required. The GPS receiver is built in, and the external GPS antenna has a magnetic base. The HSA's battery lasts up to 4 hours, but with the optional DC adapter cable, you can operate indefinitely from the vehicle's cigarette lighter socket. Here, we're using list mode to measure an assortment of broadcast, airband, mobile phone, and UHF telemetry channels. We can enter up to 20 frequency channels to be scanned, and these can be any combination of frequencies within the range of your HSA, up to 20 GHz on the N9344C model we're using here. Best of all, we can set a different channel bandwidth for each frequency. This is vital for accurate amplitude measurements of spread spectrum transmissions, plus we can still select narrow bandwidths for narrowband analog or digital land mobile radio transmissions. The HSA can be set to sweep as fast as possible, delayed by a user-defined time interval, or we can enter a user-defined distance interval, as we're using here. We've set the distance interval to 250 meters, so whenever the built-in GPS detects that we've moved more than 250 meters, the HSA will perform a new sweep of all channels and record the signal strength, time and date, and our current position to the USB memory stick. So first we'll press the green preset button to remove any strange settings that a previous user may have set up within the instrument. And before we do anything else, I'm going to turn on the GPS. So I'll press Shift, System, More, GPS. And the GPS is already on. I can have the GPS info displayed at the top of the screen. And if you want to see how many GPS satellites the GPS receiver is currently receiving, press the GPS info button and you can see here on the screen. We don't have too many because the studio has a steel roof. Next, we press the Mesh button and Channel Scanner. The buttons down the right-hand side are Scan Start, Scan Mode List. The choices there are either a list mode or the top N5 or the bottom N5. And we can here recall a previous list of frequencies that we've been scanning. But in this instance, we need to create a new list. So I'm going to press List Edit, Insert, and the first one will enter a frequency of, say, 96.1 megahertz, and a bandwidth of, say, 10 kilohertz should be wide enough to capture the carrier height. Now, here I'm entering a custom frequency, but if the channels that you're scanning are from a known frequency standard, such as WCDMA or GSM, then in fact the edit method we can change to standard and recall one of the signal standards, as shown here. I'll go back to custom, seeing as I'm going to put in my own set of frequencies. I'll insert the next one. We'll go for an airband frequency, the local ATIS transmission, 120.9 megahertz, and I'll set the bandwidth to, say, 1 kilohertz. Again, that will be wide enough to capture the carrier of that transmission. And I'll add a few more. And finally, we'll add a wideband CDMA mobile phone transmission at 882. And that will have a bandwidth of 4 megahertz. We then press Apply, and the channel list is in there ready to scan. A couple more things though regarding the setup. If I press the Setup button here, you'll see here we've got measurement interval on, set to distance. This is how we used it during the drive test. In fact, here though we had it set to 250 meters. What that means is that the analyzer will pause and not make a new measurement until it has moved a distance of 250 meters from its previous measurement point. The alternative interval type is by time. Here the analyzer will hold off making a new measurement for 30 seconds from the previous measurement, But for the purposes of this demonstration here in the studio, I'm actually going to turn the measurement interval off. Obviously, we're not going to be moving around with this analyzer here now. Now, the only other thing we need to do before we start logging is to tell the instrument where we want it to save the data, either into the internal memory or, my preference, to a USB memory stick. So if we press Shift and File, and then we want to set the default directory to USB. I'll press Return and Escape. So now I can press Logging Start, and we have the choice of saving the data either in KML or CSV format. I'll save as KML for now, and I'll give this file a name. And now if we press Scan Start, the instrument will start scanning as fast as possible because we have no delay parameters set up. So here on the channel scanner screen, you can see that the units we're measuring in our dBm. The attenuation is set to 0, which is correct. The preamplifier has already been turned on because that's the default setting for the channel scanner mode. In the left-hand column, we've got our 7 channels, our 7 frequencies that we entered with their ID number, 1 to 7. There's the frequency in hertz. So here you can see there's the 96.1 FM broadcast channel, 120.9 megahertz AM airband channel, the 4 telemetry narrowband FM channels, and here's the wideband CDMA channel. Here is the bandwidth setting that we set when we created the channel list, and here is the channel power. Now bear in mind this is not the same as putting a marker on the top of a carrier. It is actually integrating the power under the curve depending on what the bandwidth setting was. So on the wideband CDMA mobile phone transmission, it's integrating over a 4 megahertz bandwidth and receiving a channel power of minus 56 dBm. You can see the bars here indicate the signal strength by the length of the bar, but also color coding, red being the strongest and blue being the weakest. So every time the screen updates, the instrument has made another measurement of the received signal strength of each of these 7 channels. Remember, we could put in up to 20 channels into the channel list. That information, the received signal strength value, the time and date, and the GPS position is all being stored directly to a KML file on my USB memory stick that we can double-click and open in Google Earth. Now, another way we can display the data is if I press Shift Display and now select the display mode to be time instead of bar, you'll now see that this is these bars now have got time on this axis, and the color represents the signal strength. So you can see as we're driving along, the transmission may get stronger or weaker, and that is represented by a change in the color on the bars. We can also freeze this display at any time we want and refresh. The channel scanning and logging was not stopped. All we'd done was frozen the display. I'll press display mode back to bar. There are various ways we can sort the channels on the display here. For example, I can turn the threshold on, currently set to minus 100 dBm, and any signals lower than minus 100 dBm are now blanked from the display. They're still being logged, but they've just been hidden from view. I'll turn that back off again. Now, instead of sorting by ID number, we can sort by power level. Let's change the sort order to down instead of up. So with sort by power and the sort order set to down, the strongest signals are at the top of the screen. But if, for example, this channel here became stronger as we drove around, the list would be reordered and this channel here would be put nearer the top of the list. And to stop the scanning and logging, we simply go back to the channel scanner measurement menu and we can press logging stop and scan stop. All the measurements we've done so far have had the scan mode set to list. That's where we have a list of user-defined channels or frequencies that we're driving around and measuring the received signal strength of. But there's another scan mode that's especially suitable for certain applications. If I press scan mode and select top N5 and return, and now we press what's now the range edit button. Now we can enter our own custom values of frequency, but what I'm going to do here is I want to know what are the 5 strongest GSM mobile phone channels as we drive around. This is just an example. So the edit method I've selected, instead of custom, I'll select standard, and we'll select the signal standard of, not CDMA, here we go, GSM 900 downlink, and we'll recall that. And we'll tell the analyzer to begin at channel 1 and end at channel 124. I'll press apply. And without knowing any of the channel frequencies for GSM 900, if I now press scan start, you can see that the instrument is now scanning all 124 GSM channels very quickly and displaying the strongest of those in the left-hand column. Channel 83 is the strongest. It tells us the frequency, 951.6 megahertz. It's automatically set the correct bandwidth of 200 kilohertz. And the channel power, the integrated channel power, is minus 58 dBm. Similarly for the second, third, fourth and fifth strongest signals. Now, as we drive around, obviously we may get nearer to one base station than another. So the order in which these occur, in fact, bear in mind we're sweeping 124 channels, different channel numbers will become the strongest and therefore appear on this chart as we get nearer to those base stations. But of course, as with list mode, we can still log all this data to the internal memory or to a USB memory stick, and each record will contain the date and time and the GPS position. So we can open that file in Google Earth or another application. If you've logged your results directly to a KML file, just double-click the file to open it in Google Earth. That's the simplest method, but more flexibility is available if you've logged the data to a CSV file. You can edit the data in a spreadsheet and export to other mapping applications, or use the supplied KML converter software to produce color-coded maps directly in Google Earth, where the color corresponds to the received signal strength of the selected channel at each GPS location. And of course, don't forget that regardless of whether you're using the top N scan mode or the channel list, you can save the entire instrument setup, including the list of audio channel frequencies, into the internal memory or the USB memory stick. We just press Shift, File, press Save As, we select Instrument State, and press Enter. For further information on the Agilent HSA, please visit the website shown below, or contact your local Agilent representative.